Hi everybody, today we're going to talk about set operations. So far we've talked about sets as collections of objects, but often we want to compare sets or combine them to better understand how groups of items are related. This is where set operations come in. To see how this works, let's think about searching for a home we want to buy. When people search for homes online, they usually apply filters to narrow down their option. Each filter creates a set of homes that meet a certain condition. For example, maybe we want to look at the set of all homes that have pools. This really creates two sets, the set of homes that have pools and the set of homes that don't have pools. We call this second set the complement. We would say a complement is the set of all X where X is not an element of A. So for this example, a complement is the set of all homes without pools. Another way to combine sets is to use union. We would say A union B for the set of all X where X is an element of A or X is an element of B. Here we're putting the two sets together to include everything from A along with everything from B. As an example, we might have A as the set of all homes with finished basements, then B is the set of all homes with unfinished basements. If we did A union B, we would get the set of all homes that have A basement. The next operation we should talk about is intersection. A intersect B is the set of all X where X is in A and X is in B. This requires the element X to be in both of the sets A and B. This might look like A is the set of all homes with 3 bedrooms and B is the set of all homes with 2+ bathrooms. If we click both of these filters, we would get the set of all 3-bedroom homes with 2 or more baths. Our last operation is the difference of sets. A minus B is the set of all X where X is in A and X is not in B. This means we're taking anything the two sets have in common and taking those elements away. So maybe we're back to A being the set of all homes with 3 bedrooms and B being the set of all 55+ community homes. If we did A minus B, we would end up with the set of all 3-bedroom homes that are not in a 55+ community. Let's look at this a little more formally with sets. Let's start off with a universal set U that's equal to the set A, B, C, D, E, F, G, H, I, J, K. I'm going to define A to be the set A, B, C, D, E, F, G. B is the set C, D, G, H, I. Let's start by finding the union. This means we're putting these two sets together. I'll grab A, B, C, D, E, F, G from set A, then I'll add on H and I from set B. If I do A intersect B, I'm looking for all elements that belong to both sets A and B. That would be C, D, and G. When I do A minus B, I'm taking away anything from A that's also in B, which we said was C, D, and G. With C, D, and G removed from set A, I have left A, B, E, and F. If I reverse that and look at B minus A, I'm going to get a different answer. This time I'm going to the set B. I'm taking away anything that was in the set A and looking at what's left over. We know C, D, and G are a part of A, so we would take those 3 elements out. That means we just have H and I left. I want you to notice that order matters when I do the difference of sets. A minus B and B minus A are always going to be different. But when you look at union or intersection, order doesn't matter. Let's try the complement. If I do a complement, I have to look back at the universe and look at what's in the universe that's not a part of A. I know I have A, B, C, D, E, F, G in A, so H, I, J, K would be an A complement. Let's do the same thing with B. To find B complement, I'll take C, D, G, H, and I away from the universe to see that I would have left A, B, E, F, J, and K. Let's try one more. Let's do B minus A complement. To do B minus A complement, I first want to go back to B minus A, which we know is HI. The complement is everything in the universe that's not H and I. That means I have A, B, C, D, E, F, G, J, and K. Let's change our two sets. This time, A is the set of all natural numbers where X is greater than or equal to 3 and less than 10. B is a set of all 2X where X is a natural number. We're going to start by finding the intersection of A and B. You might find it helpful to write out the elements in A. I have 3, 4, 5, 6, 7, 8, and 9. Remember, don't count 10 because it says just less than. 2x means that I only have even numbers. So when I look at my numbers 3, 4, 5, 6, 7, 8, and 9, I just want to grab the even numbers, which are 4, 6, and 8. Those elements are both in A and B. Now let's find A minus B. So again, I know what A is, and I want to take out those elements 4, 6, and 8 that are also in B. That leaves me with 3, 5, 7, and 9.